As you remember, similar figures are the same shape, different sizes, and their corresponding sides are proportional. Today we're going to talk about triangles. Here's an example. We have a large triangle, ABC, and a smaller triangle, LMN. Well, LMN has a side that is missing. We don't know its length. We can set up a proportion to find the length of the missing side, LN. But first, we have to make sure we understand which sides correspond to one another on ABC and LMN. Then, we have to make sure that our ratios inside the proportion are consistent. You can see here that AB and LM are corresponding to each other because they are both the heights of these triangles. AC corresponds with LN because they are the bases of these triangles. As we set up our proportion, we'll put heights across the top and the bases across the bottom. Then we'll use our first ratio to represent triangle ABC, the larger one, and our second ratio to represent LMN, the smaller one. Now that we understand which side length is supposed to go where in our proportion, we're ready to fill in numbers. So this gives us 6 over 8 equals 3 over x. You can choose any variable you want for the unknown, but x is a good all-purpose choice. Here we can see triangle A and triangle B. They are similar also. Triangle A is smaller, B is larger. To find the unknown length of the side h, we have to figure out first which sides correspond with one another. Side h and the side length 7 are both opposite the widest angle in the triangles, in their respective triangles. 3 and 5, on the other hand, are the longer edges that are adjacent or next to the widest angle in the triangle. So now we're able to arrange these in a proportion according to each triangle. A is on the left, the ratio for B is on the right. We're going to put the opposite side lengths on the top and the adjacent or next to the widest angle side lengths on the bottom. So here we have 7 over 3 equals the unknown h over 5. Anytime you have triangles that overlap each other, it's very important to remember that the sides that correspond to each other will be sometimes overlapping too. We can very easily see that the side length 4 and the side length x are corresponding to each other because they are both on the bottom sides of this triangle. What's harder to see is that the right-hand sides of these triangles overlap one another. One of them is the side length of 3. It only goes across the top smaller triangle. The other is the side length 6, which goes all along the entire large triangle. Remember to organize your proportion before you fill in numbers. So here we see the proportion x over 6 equals 4 over 3. Now we're ready to solve, but today we'll just be setting up. The solving we'll worry about tomorrow.